Hi, today we're going to go over lesson 10.6, the introduction to circles and arcs. So first we're going to talk about a circle. We know a circle is not a polygon because there's no sides, so we can never say, look at the sides of the circle. We would have to say, look at the points on the circle, and that's how you would refer to the edges. Let's see. A circle is the set of the points all equal, which means equal distance, from a given point called the center. Okay, so my center here is A. Now, the way that you label an angle is by the center point. So since this is circle A, because you name it by the center point, you would put a big capital A, like a point. But you can't just leave it that way because it looks like a point. So you would have to put a circle in front of it. Now, if you just put a circle like this, it could be confused for like a segment OA. So you have to put a dot in the middle because circles always have like this little dot in the middle. So, and I drew a few over here as well. It's a circle with a dot in the middle and then the center point. Okay, so a circle contains radii. Now the word radii is the plural of the word radius. Okay, so it really is not correct to say a circle has radiuses. You would say the circle has like multiple radii. Just a grammar thing. So we already talked about how you name the center by its center point. The next word is diameter. The diameter is a segment that contains the center of the circle, and both endpoints are on. Remember, we say it's always on the circle. So the diameter goes straight through. So to name that, you would just name the endpoints. And so let's write down the diameter here is RP. So my question is, could you switch that and say PR? And the answer is yes, you definitely can. The next word is radius. And a radius, it has one endpoint at the center, and the other endpoint is again on the circle. So it's half of your diameter. So when you look at your picture, it starts at A, or it could start at the endpoint on the circle, and it's just this little half length. So let's see, I have a couple different colors here. Maybe if I can get them switched. All of these are different radii. Okay, good to know. Now, if your if your circles all have equal radii, then that means the circles are all congruent and equal to each other. So really the symbol should be congruent. So if you notice, R to A is 4 and D to O is 4. So that means the two circles are congruent to each other. Notice how I named them. I named it by its center point, and I put a circle with a dot in the middle. I named it by its center point and a circle with a dot in the middle. A central angle is an angle whose vertex is at the center of a circle. Now look at the word central. Central, center. It's not a coincidence, though, that those sound the same. Now this is an easy idea, and we're going to talk more about it later, but let's go ahead and kind of bring it up now. Whatever your central angle is, so let's talk about a central angle. First of all, the vertex is here at the center, and I'm just going to pick one. Notice this angle here, SAP. It's a central angle because its vertex A is at the center. Now here's the cool thing. Whatever the degree measure is of the angle, the arc that's inside the angle also has the same measurement. So if the angle is 140, the arc is 140. So that's a pretty easy thing. Now, let's go ahead and skip down here. Now, this is kind of buried, and it should have a big box with stars around it because it's important. Go ahead and circle this. This is the rule that tells us this. This is the measure of a minor arc is equal to the measure of the corresponding central angle. Okay, so that's what I just taught you. If the angle here is 50, the arc that's also inside is 50. So right below it, the measure of arc, RT, which we've really not talked about arcs much yet, but we will. Notice when we write the name of an arc, on top it is curved, so it's not to be confused with a segment. It's equal to the angle, the measurement of it, and we just found that both have a measurement of 50. Okay, now let's go back to arcs. An arc, that's not a highlighter. The arc is part of a circle. Now a semicircle is half of a circle. Now, did we talk about how many degrees are in a circle? Maybe not yet. Does anyone know how many degrees are in a circle? I thought that was in the notes. So if you don't know this, please write this down. A circle contains 360 degrees. You have to know that for this lesson. So if you don't know it, please write it down. So the next part is we're talking about half of a circle. So what's half of 360? And hopefully you know that that is 180. So you name a semicircle by the endpoints and usually another point within the circle. So let me explain. When you have this picture here, I'm going starting at D and I'm going around to C. So if I just say, all right, let's look at arc DC, do you know if I mean up and around or down and around? And you really don't know because I just gave you the two letters. So when there are two letters, you always assume it's the closest distance. Now, it's a semicircle. We know it's going to equal 180 degrees no matter what. But if it makes a difference, like if you're told to label or name all of the semicircles, it's not very clear if you write DC and DC, because technically isn't up and over this way DC and down and around also DC? So if you were trying to label them individually, that makes absolutely no sense. So here's what we do. It's really easy. I'm going to start at D, or you can start at C, and you're going to pick another point halfway through or somewhere along the path. So somewhere along this path, there is a letter A. Now, there's no confusion. You know I mean up and around. Now, you could say CAD, but those are the only two combinations for that yellow arc. So let me make a blue arc here. What's the name of that blue arc? So you can start at D or C, it makes no difference. But along this path, you come across point E. Now, again, you can flip-flop the first and last letter. The middle letter has to stay the same. Notice the arc is on top is archy, kind of like a rainbow, not straight. So these are all ways to name a semicircle. Okay. So the directions actually say name 4 semicircles within the picture. Well, we just named the first 2, which are right here. So how do I come up with the next 2? Well, I'm going to erase this picture, which I can't erase all of it. Some of it is permanently on the picture. Let's look from D to E. A to E. Okay, so let's go up and around. How would I name that? I start with A, pick a point in like along the path, C, and then E. So notice that's what I have for my next one. So let's do this yellow one. Down and around. I start at A, D's along the path, and I go to E. As I said before, the first and last letter could be switched if you really wanted to, but the middle letter has to remain. Now, when we use the words major and minor. You know what those mean. Major means something bigger. Minor means something smaller. So when I talk about a minor arc, I'm talking about an arc less than 180. And I'm talking about a major arc. I'm talking about an arc that is more than 180. Now, remember, we use 2 points when it's just the closest distance. So normally, minor arcs only have 2 points. But when you're dealing with major arcs, these must have 3 points. Okay. So, oh, look what I wrote right there. Okay, so let's name a major. Is it the next question? No. Let's name a major arc. Now, there are many major arcs here. Here's my question. Is that a major arc? No, that's less than 180. Is that a major arc? No, because that's a semicircle. Is that a major arc? And that is, because it's more than 180. So to name this, you could either start with R or start with Q. Now, along this path, you come across S and you come across the P. You don't choose both. You pick one of them. And I know the endpoint is Q. So just pick one. I'm just going to pick S because it's the first one I come across. That is a semicircle. Okay, now there are other ways to name it, but that's one way to name it. If you wanted to name it RPQ, you definitely could. If you wanted to switch the R and the Q, you could. So there's lots of variations here. So your answer does not have to be the same as mine to be correct. The measure of the major arc is the measure of the related minor arc subtracted from each other. I'll show you what this means. That probably makes no sense. I'll show you what that means in the next one. Okay, so let's start way over here. What is the measure of T, Q, R? So there's no confusion. You know I want a major arc. Now, remember, this central angle and arc RT are both 50. So to find the rest of it, this is kind of what this sentence back here was talking about. What we're going to do is we're going to take the entire circle, which that is supposed to be a circle, not an oval. It's 360 degrees, and we're going to subtract this part that we don't want. So we're left with 310 degrees. And so the measure of TQR is 310. Okay. Now, to name minor arcs, you use 2 letters. To name major arcs, you use 3 letters. And for semicircles, you could use 2 or 3, but I usually use 3. Okay, now, minor arcs. All right. When you look at this, there are lots of minor arcs. That's a minor arc. That's a minor arc. That's a minor arc. That's a minor arc. Now you could start combining them, like C to E. That's a minor arc. B to E. That's a minor arc. So I'm not even going to list them all, guys. There are so many. Now I'm not going to make you list them all because that would take forever. And we don't have time for that on this video. So just list 2. And I have a big list here. List a couple, check the list, and make sure they're on there. Now, for the major arcs, we need it to be more than 180. So start with any point that you like. Okay, that's a minor, that's a minor, that's a major. Okay, so you could write that one down. That would go from E, and you could say B or F, all the way to C. Now let's pick a different one to start from. And I'm just randomly picking something. Let's start at F. F to B, now it's minor. To C, nope, that's a semicircle. So you could go to D or you could even go to E because they're both major arcs. So again, there's lots and lots of them. Looks like I only wrote a few, and I think I wrote those right there. So just pick a couple, 2 or 3, and write them down. Now for a semicircle, you know that equals 180. So I could say DB. I wrote CF, which works C to F. And of course, you could also use 3 letters as well. Now, adjacent arcs just mean arcs that are right next to each other. Adjacent arcs are arcs that are in the same circle that have only one endpoint in common. So if you look at these two, the 32-degree angle and the 58-degree angle both share the side right here. So since they share their side, they have those in common. So to get your answer, you would just add those two numbers together. So 32 and 58 is 90. So together, they're a 90-degree angle. So what we just did by combining those, we did arc addition, and it's a postulate. Just all it says is you can add the measures of 2 arcs. It's a really easy idea. And I usually don't go into it too much because I don't want to overcomplicate it. Guys, you can just add arcs together. That's all it boils down to. So on this picture, how am I getting some of these numbers? Now, we know what a semicircle is. Now let's take that 180 right here and subtract away this 114. And when I do that, I get 66. So this angle is 66. Now, this little box, I know that means 90, which means this angle here has to also be 90. And the reason is that's a straight line. And if one's 90, if I take 180, subtract 90, I get 90. Okay, so once you have all this information written in, remember the arcs are the same thing, and we can just fill in the answers. From U to T, we already found that's 114. From S to T, we know that's 66 degrees. And from S to V, we know that is 90 degrees. All right, we're getting close to being finished. Now, if you have your index card, you need to write the formulas for circumference on it. If you don't know what R stands for, write it on your card. This is radius. And D stands for diameter. Now, what we're going to do is we're going to leave our answers in terms of pi, which means you don't type the pi button into the calculator. You just leave the pi symbol within your answer. Now, when I say circumference, this is similar to the perimeter of polygons. So if you get confused, circumference is like a perimeter. You're just going all the way around. You're not filling it in. When you fill it in, that's area. Okay, we're not doing area. We're doing perimeter. So when you do perimeters, like of a triangle or square, the unit is just like feet or meters or yards. You don't square it. So just keep that in mind. Notice over here, my unit is just plain old meters. Excuse me, I apologize. All right, so you have to look what's given to you. Since this starts at the end point or mid the center and goes to the edge of the circle, this is your radius. And so I'm just going to type or plug it into 2 times pi times radius. So 2 times 9 is 18. I bring down the pi symbol and I put my unit. My answer is 18 pi meters. Now here's the last thing before we do our last examples. You definitely need to write this on your card. What we're doing now is we're going to find just pieces of the perimeter, which we call circumference. So it's a pretty easy formula. You take whatever the arc measure is, you divide it by 360 to get a fraction of how big of the circle, and then you just times it by circumference. So write that down, pause if you need to, write all that down. So for the first one, it says find this arc. So I found this here, and it's provided to you. It's 240. So I take 240, I put it over 360 because that's what the formula says to do, and then I times it by circumference. So my formula for circumference is 2 pi r. My radius is provided, that's 15. So 2 times 15 is 30. And then I just drop down the pi symbol. Okay, so grab a calculator, see if you can get this answer. 240 divided by 360 times 30. Don't put the pi in. Okay, on your calculator should say 20, but you have to remember to drop that pi symbol down because otherwise it means something completely different. And then the unit is just a plain centimeter. On the next one, it says find the arc length of the shaded region. So this arc length is provided 120. It's always over 360. And I times it by circumference. So 2 pi r. And my radius happens to be 21. So 2 times 21 is 42 pi. So I put the 42 pi into my formula. And then I multiply it out. The way I type into my calculator, I just type in 120 divided by 360, enter, and I get a decimal. And then I times that by 42. So my calculator would say 14. Then I have to remember, drop down the pi and put the unit. Now, if you notice, the unit's missing. So if no units are provided, you just put a U, which stands for units. Last one. The arc provided is 90. It's over 360. You're going to times it by circumference. So again, it's 2 pi times radius, which is 12. So 2 times 12 is 24. So I write the 24 pi in here. Again, the way I type it in, 90 divided by 360, hit enter. You get a decimal. Times that by 24, and you get 6. So you put 6. You drop down that pi symbol, and you put the unit. All right, guys, we are finished. Yay. So if you have any more questions, please don't hesitate to message me, let me know, or come to a tutorial. Thanks a lot.